Wastewater treatment plants, especially medical and industrial wastewater, require chlorination to disinfect and kill pathogens like E. coli and salmonella, preventing contamination of natural water bodies and public health issues after discharge. However, if the residual chlorine in the tailwater is too high, it can kill fish and plankton in natural water bodies, disrupting the ecological balance. Sensors are needed to monitor the residual chlorine in the tailwater to ensure it meets discharge standards and trigger dechlorination when necessary. Wastewater treatment plant tailwater monitoring requires sensors with strong anti-interference capabilities and adaptable measurement range, as the tailwater contains impurities such as suspended solids and organic matter. Currently, the main technology is the electrode method, including the constant voltage electrolysis method and the membrane electrode method, while some scenarios use the colorimetric method. Constant potential electrolysis. This method measures residual chlorine concentration by generating a current proportional to the residual chlorine concentration through an electrode reaction. It offers fast response times, requires no frequent reagent changes, and is suitable for online continuous monitoring. It can also accommodate complex tailwater properties, such as those containing small amounts of suspended solids. Membrane electrode method. The principle is similar to constant voltage electrolysis, but the core improvement is that the electrodes and electrolyte are encapsulated in a sealed chamber, with a selective membrane isolating impurities from the tailwater. Colorimetry, based on a chemical reaction that produces color, with the color intensity proportional to the residual chlorine concentration. This method is commonly used for sensor calibration or emergency spot checks. It offers high measurement accuracy and strong interference resistance, but requires manual reagent addition and cannot provide real-time, continuous monitoring. Delfino Amperimetric Residual Chlorine Sensor utilizes a membrane-covered system, available in two types, 2-electrode and 3-electrode. The chlorine sensor offers a rich measurement range, high accuracy, and no zero calibration required. Built-in temperature compensation. The 3-electrode system allows the counter-electrode to be directly connected to the measured liquid, eliminating interference within the electrolyte. Higher accuracy, stability, and interference resistance. The use of a unique permeable membrane technology allows for a certain degree of tolerance to surfactants, reducing pH dependence. They demonstrate excellent performance in wastewater treatment. In wastewater treatment plant tailwater discharge, residual chlorine sensors not only ensure compliance with regulatory requirements, but also prevent the ecological impact of tailwater on natural water bodies at the source. They also provide accurate and traceable data support for environmental supervision and are an indispensable core monitoring device for tailwater discharge.